Okay, graphing and solving equations, those are the two things you should walk away with. These sine and cosine. If you can graph those, everything's going to be great. What I really want you to understand right from the get-go is these two graphs are identical. They're the same exact picture, 90 degrees apart, or pi over 2 radians apart. So if you can scoop one of them, you'd have the other one. Right? And that's what we're going to look at first. Before we even begin anything, we're going to look at the graphs, and we're going to see, hey, you know what? These are exactly the same pictures. Okay? So I'm going to leave this screen up visible for you just so you can see it. We're going to start with, let's see what mode. I'm in radians. I'm going to switch to degrees. So we're going to start with the sine of x. And then we'll look at cos x at the same time. And we're going to make cos x a bold-faced graph just so you can see it easier. We're going to change our window. If you're using graphic calculators with sine and cosine of x, before I change the window, I'll go ahead and graph it. You can see, you can't see jack on either of these. This looks like the cosine one is a straight line, and sine has two little dots. And the reason for that is because our window is zoomed in at the origin with respect to a sine and cosine graph. One cycle of a cosine or sine graph is how many degrees? 360. We're only looking at 10 on each side, so 20 out of the 360 degrees, we're not seeing much. Okay? So when we change the window, and I'm just going to use one cycle, I'm going to go from an x of 0 to 360, and I'm going to go by 90s because every quarter period, every 90 degrees, we have a quadrantal angle. The y values we're going to go up to and down to, let's just go from 1 to -1. And now when you hit graph, there's your sine graph. And that's one cycle. And followed directly behind is the cosine graph. And if I could push the cosine graph 90 degrees to the right, it would be the exact same shape. Does everyone see that?
Yeah.
In fact, if we take our functions and we take the cosine and we do x minus 90, and I'm just going to make this a little Ghost Rider. So you're going to see a little bubble follow the graph. So it may show all three graphs, so you may see it do sine first in regular, cosine will be in bold, then it's going to do cosine of x minus 90, theoretically. But no, they're just adding the cosine x to the other two. So you can see the cosine of x minus 90 is the exact same path as sine. We're 90 degrees off. They are the same exact graph. Okay? And you can do the same thing with the sine, shift it 90 degrees to the left, and it would land right on the cosine. Everybody follow that? Okay? So let's go ahead and look over here. Here's our two functions using the same method of graphing that I've been teaching all along, A, B, C, D. A sine B times x minus c plus d. You have two parent graphs, y equals sine x and y equals cos x. This next slide, I really would like to spend some time cleaning it up before I present it, but I didn't. It's a slide. Oh, sorry, it's not this one. It would be, well, you'll see it in a minute. Let me close this. The purple graph here is the sine graph. And I'm going to show you how to graph sines and cosines really fast, really simple. but the parent graph is up here. The red graph happens to be the cosine graph. You don't need that here. This is your sine graph. It starts at the origin. At 90 degrees, it goes to the maximum value of 1. At 180, you're back to the origin. At 270, you're down to the minimum of -1. And at 360, you're back to the origin. So you want to realize that the sine is the one that starts at the origin. And the cosine is the one that starts, oh, this is sine again. Here's cosine. Cosine starts at the maximum. So if this is your sine graph, starts at the origin, maximum, axis, minimum, axis. So when I'm going to graph a sine graph, all I'm going to do, these are all sketches, this is all you need to do your graphs. And you're going to notice over time that every single one of my graphs looks the same, whether the amplitude is 1 or whether the amplitude is 50. So all I'm going to do is I'm going to mark off my maximum value, minimum value. In this case, it's 1 and -1. And I'm going to slice it into quarters. And when I'm doing the sine graph, origin, max, axis, minimum, and we want to make this into a curve, and there's your graph. This is 360 out here. That's all there is to it. This is y equals the sine of x. And you'll see in a few minutes when we start graphing ones with translation vectors and stretches and so forth, they're all going to look like this. Every single one of them. When we do a cosine graph, for a cosine graph, I'm going to do exactly the same thing. Slice it into quarters. This is 360 out here. When I do the graph, we have a maximum and a minimum. When we do cosine, it starts at the max. Axis, minimum, axis, maximum. It takes a little bit of a practice to make it a curve. Some of you are going to, you're going to give me it's going to look like straight lines. That's really not what I'm looking for. We want it to be a nice curve. So we'll try to avoid that line deal. Right? That's as complicated as graphing needs to be. That's one period. Sometimes they're going to force you to go -360 to +360. That just means continue on in the other direction. This graph just continues to repeat. Max, axis, min, axis, max. Axis, min, axis, max. Axis, min, over and over and over again. Everybody follow that? This is y equals cos x. Now there are certain components of this graph that we're going to be concerned with. One of them is amplitude. The amplitude is easy to find. It's a little formula, max minus min divided by 2. Max minus min divided by 2. The amplitude will always be the absolute value of the vertical stretch factor. It's the absolute value of A in your function. Max minus min divided by 2. When you look on the graph, your amplitude, is the distance between the maximum and the axis or the minimum in the axis. So either of these are going to be considered amplitude. The amplitude is this distance, or it's this distance, but because it's a distance, it can't be negative. You don't ever want to say, oh, you have a -3 for the amplitude. That's not, can't be true, because it's a distance. So when you look at it in formula, maximum minus minimum divided by 2, in this case gives you an amplitude of 1. Max minus min divided by 2. You're finding the distance from here to here. Max minus min divided by 2. Your period is how long it takes a graph to repeat. How long horizontally does it take for the graph to repeat? A period is 1 cycle, and remember, B is your horizontal stretch factor. B is your horizontal stretch factor. The period will be 2 pi divided by B, or 360 divided by B, whichever one you're given. If you're in radians, it's 2 pi. If you're in degrees, it's 360. So if I'm giving you the function and you want to do the graph, you're going to need to do 2 pi or 360 divided by B in order to figure out what your new period is going to be. If I give you the graph and ask you to write the function, you need to know what B is. So we're just going to switch the period with B. So B is going to equal 2 pi over the period, or 360 over the period. So this is for graphing, and this is for writing the function. Which one do you need? You'll know the period if you have the graph. So 2 pi divided by the period will give you B, or 360 divided by the period will give you B. Everybody with me on amplitude and period?
Sorry, what do we use the equals to
Find B. B, if you remember, it's up here. B is your horizontal, the reciprocal horizontal stretch factor. So if I'm asking you to write the equation for the graph, you need to know what B is. You need to know what A is, and ultimately you'll need to know what C and D are. Okay, and we'll get to those in a second. Right now, we're just talking about, if I give you the function, you can find the period with this equation. If you take this equation and solve for B, you get those. Right? You only have to know one of them and then switch B and P. That's all you're doing. Makes it easier. Did somebody else have a question? Okay. So this is my messy page that I really need to spend a half hour on and clean it up. But I didn't. I just didn't have time. This is your original function that we talked about in graphing in general, regardless of what the function is. And in our case, we're talking about the two, sine and cosine. A, again, is your amplitude. Absolute value of A is your amplitude. It needs to be positive. B is 360 over the period, or 2 pi over the period. Okay? C and D. Well, D doesn't matter. It's the y value of the axis. Wherever the axis is for your function, when you're looking at the graph, it's the y value. If you can't figure out where the axis is because they didn't identify it, max plus min divided by 2. See how easy it would be to confuse with max minus min divided by 2, which would give you B. Oh, sorry, would give you A. So for the axis y value, the D, it's max plus min over 2 from a graph. Max plus min divided by 2 will give you B. I gave you 3 ways to find A up here. Max minus the axis value, axis minus the minimum value, or the go-to is usually max minus min over 2. Any of these 3 will work for A, and max plus min over 2 will get you D. The B value is 360 or 2 pi, whichever one you're dealing with over the period of the graph. Now C is the twist. When you have a graph and you're writing the equation, You can either give a sine equation or a cosine equation. Sometimes I'll ask you to do both, but most of the time I'll let you do whatever the heck you want. You have to commit though, and I know some of you have commitment issues. You have to say before you write the function, I am committing to sine, or I'm committing to cosine. You can't be wishy-washy on this. If you want to commit to a cosine function, then C is the x-coordinate of the max. If you're doing a cosine, C will be the x-coordinate of a maximum point. If you're doing a sine function, C is the x-coordinate of the point halfway from a minimum to a maximum, and that means from left to right. Find the minimum, right here, go towards the maximum, and go halfway, and that x value is going to be the C if you're doing a sine. It's not halfway from a max to a min. From left to right, min going to a max, halfway. That's the x-coordinate you're going to want when you write the equation. In the examples I'm going to do today, I'm going to do both equations every time. How many sine equations can you write? Technically, we could do it forever, infinite. For every picture I give you, there's an infinite number of sine and cosine functions we could write that would generate that graph. It's just a matter of which point are you using for the translation vector C and D. You're going to watch when you see the first one. All I'm going to do is I'm going to list A, B, C, D. I'm going to figure out what they are, and then I'm going to write the equation. Figuring out, I don't require you to show work. If you don't show work, however, I can't help you with partial credit. The thing that we see screw up more than anything else is C. And that happens because people have a hard time committing and they mix them up. So you want to make sure you're crystal clear on C. Does anyone need more time with this? Right here? Okay, let's look at what happens. So here is a graph. And again, don't get caught up with saying, well, this graph is the same as the first one you showed us. It's all about the labels. Because for me, every graph I draw looks the same. It's my labels that change. All right? So we need to figure out whether we're going to talk about y equals sine of x, or whether we're going to talk about y equals cos x as our parent graph. And what I'm telling you is you should do both. A, B, and D are the same for both of them. A, B, and D are the same for both of them. So let's talk through A, B, and D. Amplitude and the B value is dependent upon the period. Period can be found in a whole bunch of ways. All right? You can figure out the horizontal distance from any two quadrantal points and multiply it by 4. You could find out the horizontal distance between every other quadrantal point and multiply by 2. Or you can find a max to a max, a minimum to a minimum, halfway from min to max to halfway from min to max. And you could say, well, the period here is 360 degrees. If the period is 360 degrees, what's B going to equal? 1. So B is going to be 1 for both of these. How do we find B? Divided by the period, and we're telling you the period is 360 here. That means we didn't stretch or squish this graph horizontal. How about the amplitude? What's the amplitude? 2. It's the distance from the axis to the minimum, axis to max, axis to min, or you can do max minus min divided by 2. I don't care how you do it. And again, I don't really care if you show it or not. So the amplitude is 2. What does that tell you A is? 2. So in both of these, A is 2. How do we find D? Could do that. What else could you do? What else is D besides max plus min over 2? The what? Of the axis. The axis is the horizontal line that's halfway between maximum and minimum. You will always be able to identify it on these graphs. It's like an axis of symmetry so that the top and bottom are equally spaced. All right? And you can see these coordinates are all going to have a y coordinate of, so that means D is 0. So you now have A, B, and D. You just need to figure out your commitment problems. We're going to do both. If we're going to do a sine function, what will C be equal to? So in this one, what will it be? For a sine function? Nope. Nope. Not for a sine. Nope. Not 1. You're getting warmer though. It's going to be 0. Where is the x? Where is the value for C? What does it say? How in between? Halfway. So from left to right, you find the minimum. Going towards the maximum, it's this one right here. It's not this one right here. It can't be. This is halfway from max going to min. You have to be minimum going to maximum. Halfway is right here. So C would be 0. If we want to do a cosine function, what will C equal? 90. C will equal 90. Okay, so now you have to write the equations. So based on what we have up here, y equals sine or y equals cos, we're going to write 2 equations. So your equations, if you're going to do the sine function, you're going to get y equals, what was the amplitude? What was A? 2? 2 times the sine of x, and that was it, right? Everything else was zeros. Excuse me. So y equals 2 sine x would be a perfectly valid equation. And if we use cosine, we would have y equals 2 times the cosine of x minus 90, and again, plus 0. We don't need to put plus 0. Both of those 2 equations generate this graph right here. It will be one right on top of the other. This one's pretty easy also. The difference between this one and the last one is your period changes. Your amplitude's also different, but if we had an amplitude other than 1 on the last one. So we're going to have a little bit different setup on this. Now, again, sine, cosine does not matter. The sine or the cosine, it does not make any difference which one you do. Either way, what's the amplitude? What's the amplitude for this one? 1.5 or 1.5 or 3 over 2, whatever way you want to write it. So 3 over 2 is your amplitude. What is the period of this graph? The period is 180 degrees or pi. Right? So we're coming out to from here to here, 180 degrees. Maximum to maximum, 180 degrees. You could go from here to here, 180 degrees. Harder to see there. Right. If the period's 180 degrees, what does B equal to? 2. How do you find B? 360 over the period. The period is 180, B is 2. These are the details you need to get dialed in on. D is the same for sine or cosine. What's D going to equal? 0. D value is going to be the y coordinate of the axis. Well, this one's still using the x-axis. We're not moving there, up or down yet. Right, Andrew? Now, the C value is where you go commitment. We need a sine, we need a cosine value. So we can do the cosine value first, and we'll do the sine value second. The cosine value is easier. What is the C value if you're going to do a cosine function? Not that you don't have multiple choices, but the easiest choice for the cosine C value is 0. How do you find that? It's the what? X coordinate of the max. Well, here's a max at x is 0. You could have done out here and done 180. You could have done this one at 360. You could have done this one at negative 180. All of those will work. Folks, I'm not looking for you to be too creative on this. 0 is really the easy one.
Is C cos or whatever?
Cosine?
Yeah. Is it always going to be the same as D?
No. C is the x coordinate of the maximum. It's just a coincidence that these are the same. What about sine? What am I going to use for the C value if I decide to write a sine function? 135, we could do that. Or, not negative 90, negative 45. Push that in there. So we need a halfway from a minimum going to a max. That occurs here at 135. And it occurs here, minimum to max, at negative 45. Either one will be correct. It just doesn't matter.
Why was the period on block?
Because the distance from this point to this point was 360, or this point to this one, or this one to this one. All the corresponding points were 360 apart. This one's 180 apart. So if we write our functions for this one, if we do cosine y equals 3 over 2 times the cosine of 2x. So if you use cosine, there's no translation vector at all. The origin is still at 0, 0. Y equals 3s cos 2x means you have a vertical stretch factor of 3s and a horizontal stretch factor of 1/2 for your parent graph, from your parent graph. Remember, the horizontal stretch factor is 1 over 2, the reciprocal of b. If you were to write a sine function, you would have y equals 3 over 2 sine 2 times x, what did we say, was it 135? 135, x minus 135, and then d doesn't change, or y equals 3 over 2 sine 2 times x plus 45. Either of those functions in red would be an acceptable sine function. And the blue one, cosine, if you graph all 3 of those, you would see all 3 of them give you the same exact graph. Same exact points. infinite ways we could write this.
And at the end, is it plus or minus?
At the end of what?
At the end of like, wait, hang on.
Trick question, the first one. Y equals negative 4 sine of 3x. What's the amplitude? 4, not negative 4. Follow-up trick question. What's the vertical stretch factor?
Negative.
Negative 4. The vertical stretch factor is negative 4. The amplitude will be 4. Right? Really important to know the difference between those because this negative tells you that the vertical stretch factor is negative 4. So if I'm going to graph this, my parent graph my parent graph is y equals the sine of x. The vertical stretch factor is negative 4. The horizontal stretch factor is, what's the horizontal stretch factor? Nope. How do you find the horizontal stretch factor? How do you find it? Of B. B is 3. The horizontal stretch factor is 1/3. B is 3. The horizontal stretch factor is 1/3. The translation vector for this one is 0, 0. And you should think about, if we're going to have to sketch this, you should think about the amplitude, we said is 4, the period. What's the period going to equal? Somebody said it earlier. That's the 120. How do we find that?
360 divided by 3.
360 divided by B, which is 3. That's how we get the 120. We got the amplitude, we got the period. So again, now we're going to sketch it. Can't emphasize this enough that all of my graphs look the same, and they look the same because pretty much I'm just lazy. I'm not trying to be creative. I just want to say, here's how the graph works. So I make an x-axis and a y-axis, and I'm just going to give you one cycle. If the amplitude was 4, this is 4, and this is negative 4. And I do my best to make this distance and this distance look the same. This is one period out here. Right, Andrew? Right? Right. How much is one period? 120. So out here is 120. Needs to be labeled. Cut it in half. How much is to here? 60. Cut it in half again. 30. And then this one has to be 90. So it's easy when we have no translation vector. We don't have to really worry too much about it. It gets more complicated with the translation vector. Now, we're going to do the graph. We're doing a sine function with a negative 4 vertical stretch factor. Where does the sine function start? 0, 0 at the origin. A negative 4 vertical stretch factor has no impact on 0. So when you multiply 0, 0, the y coordinate by negative 4, you're still getting 0. We're then supposed to go where with the sine? From the axis to the maximum. But we have a negative vertical stretch factor, so we have to go to the minimum. Axis, minimum. What's next? Axis, maximum, back to the axis. So our graph is the flip of the parent graph. That's one period's worth. That's really all you need to do. If they want multiple periods, then you would continue it on. Or if they want you to go to negative, or sometimes they'll say graph from 0 to 360, then you'll need 2 more periods. And you would just continue on. From 120, go another to 240, one more to 360. All right, so here's another one where they gave you the picture, but you can clearly see that the axis of this function, which I put a green dotted line here, okay, I can take that out, but you should see that that's where the axis of the function is. Clearly, it's not the x-axis. So we definitely have a translation vector going here. So if we're going to write the equation from this graph, we want to make the A, B, C, D list, and we'll do that right here. A, B, C, and D. Again, the only concern is that you need to maybe do a sine or a cosine value for C. A, B, and D are going to be the same. If you can find any of these, A, B, or D, give me one. Raise your hand, tell me what you can find. A, B, or D from this graph. See any that you can determine? Is A 2.5? How did you get it? Okay. Think about another way that you could get it. And what's the maximum value? Look at the coordinates of the points. Do you see the highest point on the graph anywhere?
Oh, yeah.
Do you see what the maximum value for that point is? What? What's the minimum value for any point on the graph? Minimum value. 1. So, which is 5. So A, the amplitude is 5, and I would never try to make A a negative number. That's just silly. You can do it, but it's really silly. How about another one? We have 2 more that you should be able to find straight away without much thinking. How did you get 60? 360 over... B does equal 2. How do you find it?
I got like 1 point and it's I'm not explaining it though.
Okay, we need to be able to explain it. How do you find B? What's the formula? It's a real easy formula. But what's the formula? 360 over the period. So in order to figure out that B is 2, you got to find the period. Which points did you use to determine the period? So this point, and which one? 105. Those are both halfway from min to max. 105 minus a minus 75 is 180. 360 divided by 180 gives you a B value of 2. And the easiest of all of these to find is D, which is, and how do you get that? Okay, or easier than that, look at what? Look at the point on the axis. Any of these points that are identified on the axis. Okay? C is the commitment one. If we're doing sine, what would you like C to equal? So, not for a sine, it's not. 105 would be 1, or negative 75 would be the other, based on the picture. You either need this point x coordinate 105, or this point, x coordinate negative 75. Either of those works. Now, if you're going to do a cosine, you really only have one point that's given to you that you can use, but you could find another one. I just don't know why you would. What would you use for C if you're doing a cosine? Negative 30. It's the x-coordinate of the maximum, which is this one, or the x-coordinate of this maximum, which we really don't know, but we could add 180 to it and find out that it's 150, 11. I just don't know why you would want to do that when they've already given you a value. So that means we have multiple choice answers that we can give. We could say y is equal to 5 times the sine of 2 times x minus 105 plus 6. You could do y equals 5 times the sine of 2 times x plus 75 plus 6. Or you could do y equals 5 times the cosine of 2 times x. What was the c for cosine? Negative 30. So plus 30 plus 6. Any of those three would be correct answers. Not that there aren't more, but that's 3 of them. 3 correct responses for this. I don't care which one you come up with. Is there anybody who's not sure of how we're getting? Here's another one. Oh, is that the same one? I think it's the same picture, right? Right? So here's one that goes to radians. Here's one that goes to radians. And again, we want you to be able to graph it. See this graph that we're going to do right here? See how they have graph paper here? Not going to happen. Not for me. You're welcome. You OCD folks, graph paper away. Me, not going to happen. No way, no how am I going to be graphing this. All of my graphs are done like that. What you need to figure out are the details. So you need to know what's the period, what's the amplitude, what's the graph going to look like. So we know that we're talking about a y equals cos x. We know that A is your vertical stretch factor. And we know that that's, again, negative 4. So we know that this cosine graph is flipped, so we're starting at the minimum. Again, we have no translation vector, unfortunately, but we do have a b value, which means we have a horizontal stretch factor that is technically, what's the horizontal stretch factor? No, 3 over pi. And our translation vector is still 0, 0. The period. What's the period going to equal? What is it? 6. How do you find it?
Just 2 pi divided by pi.
2 pi divided by pi over 3. So if you need to work that out and show that, 2 pi divided by pi over 3, 2 pi divided by b, 2 pi times 3 over pi, the pi's cancel. Gives you a period of 6. If you need to show this, have at it. If you don't need to show it, I'm fine with that too. What's the amplitude going to be? And that's probably all you're going to need to show our graph. For me, again, I just, 4, negative 4. Slice, slice, slice. How far out? All the way. Can you see it? What's this going to be? 6. What's here? 3. 3 over 2. And then halfway between these would be this plus this in this case. We don't always have that option, but it's going to be 9 over 2. Okay, it's the average of this one and this one. 6 plus 3 is 9 divided by 2, 9 over 2.
Is the horizontal stretch factor the reciprocal of B?
Correct. 1 over B. 1 over B is the horizontal stretch factor. Always. Because this has a vertical stretch factor that's negative, and it's a cosine function, instead of starting on the max, we start on the minimum. And then it's axis, maximum, axis, minimum, and that's all we need. Sorry. Oh, really? Over the top. And that's all you need to graph. If they ask you to go out to 2 pi, how much further do I have to go? If they ask you to go out to 2 pi, you know, graph from 0 to 2 pi, how much further do I have to go? Not 0.3, 2 pi. Well, it's, yeah, 0.28. It's close to 0.3. You could put one more slice out here if you wanted to, and just take it up to there, and you're good. You've covered all the way out to 2 pi. 2 pi is like right here. Okay? Somebody had a question I didn't answer. Okay, we're going to get started with the equations, but not going to probably make it all the way through. You need to know in advance this is going to be a little bit tricky. And we want to avoid it being too complicated. You already have the tools. We've already talked about the trick in this, but you've got to really be meticulous in your work. This says give to the nearest hundredth. We're always going to go 3 decimal places, please. This is our equation. Sine of 2x equals 0.7. There are some people who believe, oh, you should graph it, and you'll be able to tell it so much easier. If you've had me before, you know my feelings about graphing. Graphing is a pain in the butt. There's 2 issues for me with graphing. What are the 2 issues? What's that? Yeah, I'm lazy, but that's not one of my issues with why I don't like to use graphing. Accuracy is a big problem, and then more important for me, because my lazy thing, it takes forever to graph this. So I think you're going to be better served not graphing, and I'm not really going to talk about, you could graph y equals sine of 2x, and you could see, hey, you know, here's where 0.7 is. You can see that it's going to happen 4 times in 0 to 360. Yes, this is wrong. Okay, they can't both be or equal. Okay? So sine, no. Well, it says give answers of radians. I think that's just generic for everything. So if you get, I just want you to put everything into 3 decimal places. So I don't mean to give this answer in terms of radians because we said degrees, but if they tell you 0 to 2 pi, you're going to be doing radians, you do the same thing. So either way, whether you do degrees or radians, 3 decimal places. Because of the domain restriction, you would do this in degrees. I think that there's just confusion on when we look at this question. So we want to start with the equation. Sine of 2x is equal to 0.7. You want to ignore the 2x and treat that as what you're finding the sine of. So when you go through this, 2x is going to equal sine inverse of 0.7. 2x is going to equal sine inverse of 0.7. See if you can figure out what sine inverse of 0.7 is. That, well, some people may have memorized it, but I, I personally am going to need to use a calculator. And make sure you're in degrees. Okay?
4.47.
How much?
444.47.
I have a very hard time believing that your calculator gave that answer. To the nearest 3 decimals.
Okay. I didn't know if we should count.
44.427? Is that what you said? Oh, I heard 400.
Oh, that's a 44.
Okay, yeah, 44.427, that's good. Okay? 44.427. Don't do any work with that. Okay? Because you need to also realize that that's only one of the 2 possible answers. One of the answers is 44.427. You need to come over here. Here's your 44.427, and you whip a little all students take calculus on this one. Where else is the sign going to be positive? Quadrant 2. We will eventually, but don't try to go there too quickly, because then you'll end up getting wrong answers. Treat the 2x as one entity until you figure out all the possible values for 2x. So what's the other angle in quadrant 2? 135.573 degrees is your other angle. How do you find an angle in quadrant 2 if you know the reference angle? 180 minus reference alpha or reference theta.
You subtract 180 by this.
Okay, so now we're going to have 2 equations.
Oh, okay. But that wouldn't matter.
2x equals 44.427 degrees, or 2x equals 135.573 degrees. If you divide by 2 here, what do we get? 22 what? 214 degrees. So that's going to be one of our values. When you divide by 2 here, x is going to equal and a lot of us are going to be doing the touchdown dance right now. Okay? Or LeBron and his baby powder, because you think, yeah, look at me, got him. Uh-huh. Problem is, you only got half of them. You only got half of them. So you need to realize that because you're going from 0 to 360, if you were to look at, and I'm not suggesting this, I'm saying just if we did, here's 180. Here's the sine graph. You would come up, you would do this. That's what we've looked at so far. And you found these 2 right here. But because the graph continues like this, there's going to be 2 more over here that also. That's exactly what you do. You come up here and you say, look, b is 2 right here. If b is equal to 2, therefore the period of our function is how much? 180. How do we find that period? What was it? 360 divided by 2. You're going to, the easiest way to do this is solve the way we just solved, and then keep adding 180 to each of your answers until you go out of bounds. What's out of bounds? That's 360. So we're going to add 180 to this, and x could also equal 202.214 degrees. And we add 180 to this, and x could also equal 147.786 degrees. If you add 180 to the 202, out of bounds. If you add 180 to the 147, out of bounds. So we don't have to add any more. But there are 4 answers for this problem. And the best thing is you can take any one of those answers and plug it back in here, and you should get about a 27 when you do the sum. What did I write? Yeah.
Oh, yeah,
Did I say 247?
Should one.
I think I said it in my hand, just didn't do it.
Okay, so you add those answers?
Nope. Okay, so there's another example here, and then this is the assignment. Hopefully we're still matched up on the calendars. This is your assignment that you're going to be doing.